Hello, everyone. Thanks for being here. I'm Vicente, and today I want to share with you some advanced techniques for creating agents in Globant Enterprise AI. My goal is simple. We're going to go beyond theory and show you in a practical way how and why we create agents and how to build them. All right, first, let's start with why agents and not just LLMs. Look, an LLM is a large language model, and it's a very good model for generating text. Basically and essentially, what an LLM does is predict the next word. As you can see in the example, we have a question posed to the LLM. What is 1 plus 1? So what this LLM will do is predict which word is most likely based on the question. It has options. For example, it can choose the number 2, 3, or anything else. So based on its training and all the data it has seen from the LLM, it chooses option 2. Obviously, this is very good. It does it really well. The LLM works so well that it makes you think it's actually thinking or doing something interesting. The thing is, the LLM doesn't have a mechanism for making connections. It doesn't have memory. It's not like it searches a database or does anything like that. An LLM does nothing more than predict the next word. Specifically, the next token lets understand a token as a word or a small part of a word. That's where the agent comes in. The agent gives the LLM those capabilities it lacks. We can make an analogy. An LLM can be thought of as the brain, while an agent acts as the nervous system. The agent gives it capabilities, for example, to plan, to break down its tasks into smaller ones. It gives it the ability to remember. With this ability, the agent can recall a past task or a previous problem. It can assign tools to it. And this is super important because when an agent uses tools, it must be able to allow the agent to take actions. And not just create a chat I can talk to. Now it becomes an autonomous entity that can take actions like querying a database, downloading documents, reading my file system, and so on. So with the agent, I go from a sophisticated chatbot to an autonomous and functional employee. So everything I'm talking about is strongly supported by statistics. For example, according to Gartner, it's believed that at least 15% of decisions will be made by agents in 2028. It's also believed that 33% of business applications will include agentic AI. And it's also known that in technical fields like programming and code generation, there will be a 50% improvement. So let's move on to explain the architecture of an agent in Globant Enterprise AI. The foundation is the LLM. The LLM, as I mentioned before, is the brain of the agent. Then we have elements like the prompt. This prompt will define which instructions, or it will define the agent's personality. We have memory. What memory does is store data, previous conversations, or past problems that the agent has solved. This is very important because it greatly improves the agent's context. We have strategy. With strategy, we decide how the agent will think and how it will solve its problems. And we also have tools, as I mentioned before, which allow it to connect with the outside world, or even with its own agents. An agent can make use of its own agents. This makes my agents very versatile because I can have a very complex agent that divides its tasks among other agents who are specialized in each subtask. Finally, we have the guardrails layer. This layer provides security for the agents. It filters any input and output, obviously, to prevent any prompt injection or jailbreak attacks. So let's move on to how to choose the best LLM. This depends a lot on the agent's task. The recommendation is that we first understand what we want our agent to do. And based on that, choose the best model. For example, if I want my agent to make use of tool calls, in this case, let's say I wanted to connect to a database. So here, the best models that have proven to be very good are GPT 4.1, GPT 5, or the Gemini 3.5 Pro models. We can also use models from, well, there are also more complex models that are specialized for reasoning tasks. In this case, GPT-5 Codex, GPT-5 Pro, or Gemini 2.5 Pro are the ideal ones. For example, for tasks like programming, in this case for agents, well, the best models that have shown the most versatility are the Claude models. And well, we also have, let's say, if I want to optimize the response time of a model, let's say for a problem that's not that complex, but I'm really interested in having the lowest possible latency. Here, I can go for smaller models like Gemini 2.5 Flash or GPT-5 4.1 Nano. In Globant Enterprise AI, we can choose which model we're going to use. When we create an agent, we have a configuration panel to choose the model, and those models are grouped by each provider. Currently, we keep up to date with every model that comes out at the cutting edge. Now, let's move on to the reasoning strategy. This tells the agent how to fake. The most basic one is chain upon. In this case, what the agent does is structure its work step by step, breaking the work down into several tasks. It's the most versatile for most problems an agent will face. We also have something more complex, which is reflection. In this case, what we do is have the agent, before delivering the output to the user, think through reflections about what it's generating. This is really good to make sure that the agent's output is free from errors and hallucinations. We also have the tree of thoughts. This is much more complex because in this case, the agent generates several possible solution paths and then, at the end of the whole process, chooses the best solution. This is the most ideal for problems that are very complex or require a lot of reasoning. And finally, for users who aren't very technical or have little experience, we have dynamic prompting. In this case, this agent helps the user ask better questions, structure them better, and focus them more effectively. Similarly, when you create an agent in Globant Enterprise AI, you can define which strategy it will use. This is located in the right panel, right next to where I choose the model. Now let's move on to temperature. These are very important parameters. Temperature determines how creative or how deterministic my agent is. For example, a temperature close to zero makes my agent as deterministic as possible. That is, if I ask it a question, it will make the answer almost repetitive if I ask the same question again. This is very good for problems that require information retrieval, data extraction, code generation, or some type of mathematical reasoning. On the other hand, we have a temperature close to 1. In this case, the agent's very creative. The agent uses a lot of randomness. This is very important for tasks like creative writing, brainstorming, or generating new plans or new products. Here, I want the agent to be as creative as possible. And here, I can choose a model with a temperature close to 1. The next parameter is max tokens. In this case, max tokens limit the agent's output. That is, if I, for example, ask my agent the question, "Who are you?" the agent will respond as you see there. I am an agent that stops there. Why? Because I set a maximum of 5 output tokens. Remember that tokens can be words or small portions of words. So when I limit these max tokens, I limit the output that the agent generates. The main goal of this is to have control over costs because the models charge based on the tokens they generate as well. So if I want to limit and manage the cost of my models and agents, I can choose to limit these max tokens. The advice is to carefully analyze what type of task we're going to do, and based on that, set a maximum value for each task. Another super important parameter is max calls. Max calls can define how many times does the agent make a call. Generally, calls happen when an agent uses tools or sub-agents. For example, in this case, we see that I'm asking the agent to do a web search for me. It's a web search agent, and I'm asking it to give me news about LLMs. So this agent is first going to use a tool called web search. That's already one call. And then it's going to call more tools that do web scraping to extract the content from each page. In this case, we see that it used 4 pages. In total, the agent made 4 calls. Why's that? Because in this case, we've set max calls to 4. So this is super important because depending on the agent we have, we need to know roughly how many calls it can make. That is, if I have a web search agent, the recommendation would be to set max calls to 10, for example, because it needs to do a lot of web searches, scrape the internet, and maybe then generate a report. However, if I have an agent that isn't going to need to use tools much, then it might make sense to set max calls to 3, 2, or even 5. This is important because it prevents those infinite calls that can happen with other types of agents. Also, all these parameters I mentioned can be configured in Globant Enterprise AI. We've given temperature a much friendlier name. We call it the creativity level, which ranges from 0 to 1. Max tokens keeps its original name. And for max calls, we've given it a synonym here, which is max runs, which basically means the same thing. All right, now let's move on to tools. Tools are what actually give agents their power to act. In Globant Enterprise AI, we already have predefined tools. We have tools for web sales, tools that connect to Jira, Google Drive, SharePoint. We also have tools that send emails and even tools that can execute Python code. However, a user can also create their own tools. A user can create a tool based on an API. For example, I might have an API that returns information from my company's database. So I can create a tool that connects to that API, and I already have all that computational power. In the same way, I could have a tool that creates documents for me, reads my file system, etc. This is really only limited by the creativity of the users. Similarly, we also support a connection with MCP tools. MCP is a new paradigm that has emerged, a new approach that allows you to create tools in a much simpler way, and that can be used with multiple agents. There are many predefined tools with countless actions, and the good thing is that Globant Enterprise AI can make use of these MCP tools, which really expands the possibilities for an agent in Globant Enterprise AI. All right, now let's move on to prompting. Prompting is the way I give instructions to the agent. Normally, you use plain text, like in this case. In this case, you can see that I'm creating an agent, which is a web agent, and well, I read the instructions it needs to follow. Okay, the plain text I use to give instructions to my agent isn't the only way. It has already been shown in several studies and also from personal experience that I can use Markdown, XML, or JSON. These elements serve to improve things. In several tests, it has been shown that, for example, using XML to delimit the agent's instructions significantly improves the agent's performance. Of these three, they're ranked by how effective they are, with JSON format given the best results. However, this one can be a bit tricky for a user to write. My recommendation is that we use a combination of these last three. Personally, I often use a mix of Markdown and XML, and it has given me very good results. This agent prompt is defined by 3 attributes when you create an agent that's going to be used in an AI class. We have the fields, background knowledge, guidelines, and examples. These 3 fields are ultimately concatenated into a single one, and they define the agent's prompt, which will determine the agent's personality as well as the instructions it needs to follow. As you can see in the example, in the guidelines, I'm using a combination of Markdown and XML. Now let's move on to the topic of security, which is super important at the organizational level. For security, at Globant, guardrails have been implemented. Every time a user makes a request to an agent, before it reaches the agent, it goes through a security layer. This is called the input analysis guardrail. This guardrail analyzes the input and looks for prompt injection or jailbreak attacks. These are very common attacks on agents that aim to steal information, view private data, or make the agent behave in a way it shouldn't, in a way it wasn't programmed to. We also have another guardrail, which is the input moderator. In this case, what this guardrail does is it checks that the user's input complies with certain guidelines. For example, it blocks violent content, sexual content, or illegal content, or any content that the company requires not to be passed on to the agent. Similarly, when an agent generates an output, we have a layer that analyzes that output. This layer will filter out, for example, malicious code, malicious URLs, or any content that might have slipped through the agent. These three security layers ensure the reliability and good performance of agents, and users can even add new security layers according to their needs. Now, the agent-to-agent pattern or framework is also very well known. This is a way to establish communication between remote agents. At Globant Enterprise AI, we also support this capability. That is, we can have an agent created in Globant Enterprise, and yet this agent can connect to or interact with another agent. Therefore, it could be created in another tool, for example, an agent in LangChain, an agent in AutoGen, or ADK. This greatly ensures interoperability between agents and allows not just integration, but also the solving of very complex problems that may require agents created on different platforms. Well, finally, to wrap up everything we've explained, let's create an agent. Let's see how this agent works. It's a deep search agent that performs deep searches on the web and generates a very well-prepared report. This agent will use three sub-agents. There will be an orchestrator agent, which is the agent responsible for improving the user's input and for understanding what the user wants to search for. And this orchestrator agent will also be in charge of organizing and assigning tasks to the other agents. We have a data collector agent. This agent is very important because it is the one responsible to collect information from the web. As tools, you can see that it has web search and web scrap. In one detail, this agent will use the Gemini 2.5 Flash model. This model is very good in this particular case because it supports up to 1 million input tokens. And I want that because when it analyzes web pages and extracts content, the amount of information can be very large. And I want a model that can handle that magnitude of information. And finally, we have the reporter, which is the agent that creates the final document. This agent can create a document in Google Docs, a PDF document, or even in Google Sheets. All right, so let's see how this agent works. As you can see there, well, that's the Google Sheet where the references from my document will be created. In that drive, my document will also be created. And now let's see how the agent works. In this case, the agent is being asked a question. It's being told to look for new trends in artificial intelligence that are related to LLM agents. The agent starts doing its job. It begins to work. In this case, it started by using the data collector agent for information, and as you can see, it's putting together all the content. We can also see the sources that this data collector used. There it shows the URLs of the pages it has evaluated. Now it moves on to use the next sub-agent, which is the reporter. What this one does is generate the document to create the final report. So here we wait a bit. It's already generated the documents it has created too. The first is a Google Doc, which it saves in the Drive folder I showed a moment ago. Here we can see that it has created several sections, several subsections, where it has summarized all the content it found on all the web pages I searched. I see that. The agent started searching for web pages, extracting the content from each web page, and with all that info, which was a lot, it condensed it into this document. Also, to better ensure the quality of the information needed, this agent has created a Google Sheet where, in this case, we have the references. There we can see that we have the URL of each reference the agent used to retrieve information. We have the title of that page, and this agent has even generated a short summary for each page it found. This really validates and ensures the quality of the information the agent is presenting in its document. All right, now let's move on to technically explain some details about this agent on the platform. Here we have the three agents. The deep research, which I mentioned a moment ago, is the one that orchestrates all the subagents and other tools. We have the data collector. Let's start with this one. As I said, it uses the Gemini 2.5 Flash model because it handles a lot of information. Notice that for max tokens, I've also set a very large value, about 43,000 tokens, because I need the generated information to be fairly dense content. And let's not forget that I chose Gemini 2.5 Flash because this model supports up to 1 million input tokens. So this ensures that the information I get from the internet fits within that 1 million token limit. As for tools, this agent has tools like this web search and this web scrap, and it also has tools that access scientific article databases. We have a tool that accesses the RSIB database and also PubMed. All right, let's move on to the people who generate the report and the final document. These folks, well, they're using the GPT 4.1 model, which is versatile for reviewing stories and also has other tools. In this case, this agent has tools for creating documents in Google Docs, which are already predefined, and they're going to interpret them. It has a tool for creating PDFs and also tools for accessing and modifying data in Google Sheets. Let's not forget that this, in the end, was the final report and the document in Google Sheets. And this is the main agent, Deep Research. If we look at the tools section for this agent, we see that it uses the data collector and report as subagents. These subagents are the ones that handle data collection and, in the end, create the document. We've also used chain of thought prompting as a fine-tuning strategy, which in this case is very effective because it helps the agent structure its plan and generate several steps it should follow. If we go to the settings and look at the prompt use for this agent, we'll see that we've chosen a combination of XML and Markdown. This, as I mentioned before, really ensures the good performance of this agent. With this, we conclude the presentation. Thank you very much for your attention. Let's remember that guide agents not only represent a technological evolution, but also a new way to enhance human talent and scale intelligence.